It's the universal law of frustration. The moment you switch to the faster lane on the highway, it grinds to a halt. Meanwhile, the lane you just abandoned is flowing past you like a river of mocking headlights. It feels like a personal curse, but it is actually just cold, indifferent mathematics. No one is targeting you. The universe, it seems, is simply using game theory to ruin your morning.
In fact, a study in Nature proved that even when two lanes move at the exact same speed, you'll still think you picked the slower one. Your brain is a terrible calculator. You only count the seconds when you're losing.
To understand why this happens, we have to look at the highway as a network. In game theory, when every driver looks out only for themselves, trying to find the fastest way home, the system gets stuck in a Nash Equilibrium, a mathematical stalemate where no one can win. This is a state where drivers switch lanes until no single person can decrease their individual travel time, TI, by switching. The irony is that when everyone acts selfishly, average speeds equalize, but at the absolute maximum level of collective frustration. You might assume adding more lanes is the cure. It isn't. Under Braess's paradox, adding capacity to a congested network can actually increase total travel time. When a new lane or shortcut is opened, selfish routing draws too many vehicles into the bottleneck, which just makes it worse for everyone at once. The new road doesn't relieve congestion, it coordinates it.
Adding roads only makes it worse. To find the real solution, we have to look at an organism that solved traffic millions of years before the car was even invented. This counterintuitive behavior isn't unique to roads, it is a fundamental law of physics. We can prove this with a simple mechanical model, a weight suspended by two springs and a central string.
Intuitively, if you cut the central string, you expect the weight to drop. But because of how the tension shifts between the springs, cutting the string actually causes the weight to rise by several centimeters. In traffic, closing a road is like cutting that string. It can lift the load and make everything flow better. But traffic isn't just about tension and strings. It behaves like something much more unpredictable, a liquid. To understand the why behind the stop, we have to look at the highway not as a road, but as a fluid. Even if everyone stopped switching lanes, you would still hit those mysterious stops that have no accident or construction at the end. Traffic behaves like a mood ring. It shifts from a free-flowing gas to a frozen solid the moment it gets too crowded.
This critical point is called the jamming transition. It is the exact same physics that explains how sand grains clog in an hourglass or how liquid glass solidifies without freezing. Once traffic density crosses a critical threshold, rho is greater than rho crit, the cars are packed too tightly to move independently. At this tipping point, the highway behaves like one giant frozen block.
A Jamiton, a traffic wave soliton, is born when a single driver taps their brakes for just a fraction of a second. The driver behind them overcompensates, tapping theirs harder. This creates an emergent, self-sustaining wave of brake lights that propagates backward through space at roughly v-wave of minus 20 kilometers per hour, about the speed of a slow walk, but in the opposite direction, defying the flow of the cars themselves.
This wave grows because of human reaction delay, tau, of about 1.2 seconds. The time it takes for your brain to process the brake light ahead and move your foot to the pedal causes you to overcompensate. Basically, your slow brain is a traffic jam machine. But don't feel bad. Ants have actually solved this already. Yes, leafcutter ants move in dense millions without ever causing a traffic jam. They do this by dividing their trails into dynamic lanes,
roads. Outbound ants go on the edges, while inbound cargo carriers take the center. More importantly, ants never tailgate. If an ant in front slows down, the ant behind matches its speed instantly, with zero reaction delay. They operate as a collective superorganism. By eliminating selfishness and reaction delay, they completely bypass the jamming transition.
We can achieve this same efficiency if we remove the human driver. Imagine an autonomous swarm of cars communicating via 5G at 1 millisecond latency. Without human reaction delays, they wouldn't need traffic lights. They could weave through intersections at 100 kilometers per hour, passing inches from each other in a coordinated ballet, moving the system from a selfish Nash equilibrium to a cooperative social optimum. But until the robots take over, you can break the physical wave yourself. By refusing to tailgate and maintaining a large, constant buffer space in front of your car, you act as a traffic shock absorber. When the car ahead brakes, you simply glide forward, absorbing their speed dip. You prevent the reaction delay, tau, from cascading backward, dissolving the Jamiton entirely. So, the next time you are stuck, stay put, leave a gap, and let the wave dissolve. If you want to keep exploring the hidden physics of our daily frustrations, subscribe and let us calculate the next bottleneck together. Thanks for watching. Stay silly.